Alright, so good night. I'm going to say what I did on day 2. Last time I was doing problems about sets, and basically I did a few. I'm going to show here. Last time I didn't finish doing exercise 12, I was tired. I did one exercise that was in the text, like suggested, then I did 12a. I did this by doing a drawing because I don't know a better way of doing it or a more formal way. Exercise 13, a bunch of like sub questions. Got kind of stuck here, but I realized I wasn't expanding like enough, so after I did that it was good enough. Here I remember doing an exercise like this in my probabilities class in like high school, and I want to know if there is a way that I can come to here without this text, because I thought about it and like I can't think of anything. Then for exercise 15, yeah, just use the hint that the author gave me. And for exercise 16, I couldn't solve it like 100% because I'm missing something. In this case, I'm missing m of a intersection b, which is the numbers of the sets intersection between a and b, and I couldn't get it into this formula. Maybe I'm just too tired, I don't know. And I left some exercises that I will try tomorrow, like before I turn on my computer, I guess. And yeah, these 3 and 4 exercises are from a new chapter, which is mappings. So mappings is basically a function, and this reminds me of linear algebra, where we cared about stuff like if it's subjective and if it's injective. And here are a bunch of examples, 10 examples, and then the author tells us like which mapping, like in this example it says what's onto or subjective, and then says in which examples it was according to this definition and which weren't. And then there are a lot of definitions that I'm going to have to reread tomorrow just to be sure, and some that are left as a proof to the reader. Hold up, we leave the proof of the next remark to the reader. And on the problems there are also some which give a proof of the remark, so I think I'm just going to do the problems. And if you see, there are like a lot of problems, like 11 easy ones, and then 10 medium ones, and then 14 hard ones. The ones that I'm most interested about are these with the asterisk, because they mean something like they are important to prove a definition that will come later, or is important for some future material. So yeah, that's the ones that I'm going to care most about. Yeah, something that from yesterday. So I didn't exactly understand this question, and someone told me that this, well, I'm going to say mapping now because it's not a map. Well, it's a mapping, yes, it should be a mapping. But it says that this symbol, or mapping between A, this symbol B, is called a hair. I'm not sure if I'm pronouncing it right, but I think it says in Harrington, so hair. But I'm still not sure about like what exactly, if this is like a consensus on what this mapping does, like if it's like a plus or a minus or something, or if just it is just used as an example. I think it's just used an example, and I have to think of it as it's any sort of mapping or function. I didn't have time to review this, so yeah, it's the same as yesterday, and hopefully I will change it tomorrow based on what I know now. And yeah, I think that's all. Thanks for watching and goodbye.